Good evening, everyone. I'm Bhargav, and I'll be introducing AlgoViz, our interactive learning tool designed to make machine learning algorithms accessible through dynamic real-time visualizations. AlgoViz supports both supervised and unsupervised machine learning algorithms and is designed for learners from beginners to advanced. This is our main agenda for today, what we'll be discussing about. Why did we create AlgoViz? Our goal was to demystify complex machine learning algorithms through visual explanation, bridge the gap between theory and implementation, and provide a self paced learning and experience suitable for classrooms, tutorials, and interview preparations. Our mission with AlgoViz is simple to make machine learning understandable, engaging, and accessible to everyone. We aim to transform complex theory into clear visual understanding, helping the next generation of thinkers, builders, and problem solvers learn by seeing and doing. Next on to Arun. Sorry, Chanchal.
Key features and tech stack. Hello, I'm Chanchal and I'll be introducing key features and tech stack. AlgoViz offers interactive visualization that brings algorithms to life. Real-time parameter adjustment to see immediate effects. Comprehensive algorithms explains with practical applications. A user-friendly interface accessible to all skill levels. For our tech stack, we built the front end using React.js to create an interactive UI. The backend was deployed with Flask in Python, handling algorithm execution, data processing, and API endpoints. We utilize core libraries like PyDot, GraphViz, and scikit-learn for visualization and algorithm implementation. The application is hosted on Firebase with backend deployment via Google Cloud, ensuring fast and reliable performance with PWA features. Thank you. Now, Arun will continue.
Hi everyone, I'm Arun and I'll cover the first part of our supervised learning algorithms. Firstly, K nearest neighbor or KNN. The algorithm classifies or predicts new data points based on the kth nearest labeled point. It's commonly used in recommendation systems and handwriting recognition, working best with low to moderately sized structured numeric or categorical data sets. Next is polynomial regression. This algorithm fits a polynomial function to capture a nonlinear patterns between input features and continuous output. Its idea for forecasting, financial trend analysis, and physics modeling, working with structured numeric data where relationships are nonlinear but smooth. Finally, decision trees. These split data into branches based on feature conditions, forming a tree structure for decision making. They are widely used in medical diagnosis, customer segmentation, and fraud detection, handling both categorical and numerical data effectively, even with missing values. Now, Priyanshu will take over.
Good evening, everyone. I'm Priyanshu. I'll continue with the supervised learning algorithms. So, support vector machines. This algorithm finds the optimal boundary between classes for classification of fits the hyperplane for regression. SVMs excel in text classification, image recognition, and stock price estimation. They work particularly well with structured, high-dimensional data like text vectors or image features and are effective on small to medium datasets. Artificial neural networks. ANNs simulate layers of neuron to model complex patterns for both classification and regression tasks. They are widely implemented in image classification, time series forecasting, speech recognition, and customer churn prediction. ANNs are versatile, handling unstructured data like text, images, and audio, as well as complex structured datasets with both linear and non-linear relationships. Now, Darsh will continue.
Unsupervised learning. Hello, I'm Dash Patel and I'll be discussing our unsupervised learning algorithms. K means clustering. The algorithm clusters data into K groups by minimizing the distance to cluster centroids. It's commonly applied in customer segmentation, document grouping, and image quantization, working best with numeric data and forms relatively uniform spherical clusters. Uh, DB scan clustering, unlike K means, DB scan groups densely packed points into clusters while marking low density points as noise. It's particularly effective for geospatial data analysis, anomaly detection, and event pattern recognition, handling spatial or numeric data with irregular cluster shapes and outliers. Principal component analysis. This technique reduces dimensionality while preserving variance using a new or orthogonal components. PCA is valuable for data visualization, feature reduction, noise filtering, and pre-processing for ML models. Working best with high-dimensional numeric data like sensor readings, image pixels, or gene expression data. Now, over to Tanisha.
Hi everyone, I'm Tanisha and I'll discuss the challenges we faced and our conclusion. We encountered several significant challenges. First, implementing highlighting features and interactive elements like shadows and distinguishing data points was time consuming. Second, optimizing user interaction and data addition to the canvas required careful design. Third, making algorithms iterative with play stop functionality was complex, especially returning data list after each iteration. Fourth, achieving results equivalent to established library like scikit-learn demanded meticulous implementation. Finally, handling animation and plots, particularly for decision tree with proper color coding, required significant effort. In conclusion, algorithm AlgoViz transform complex machine learning algorithms into iterative data-driven systems that deliver intelligence at all levels. By bridging theoretical concepts with practical visualization, we enhance understanding and foster deeper insights into algorithm behavior. We invite you to explore our live demo at algoviz.web.app or contribute to our GitHub repository. Thank you for your attention.